Assalamualaikum and a very good afternoon to Prof. Nurihan and all my fellow friends. My name is Sarah Fatihah binti Mubarak with matric number GS59565. Today, I would like to present my research proposal entitled Application of Oil Palm Kernel Shell Activated Carbon for the Treatment of Palm Oil Mill Effluent Final Discharge by Batch Experiment. I am supervised by Professor Dr. Suraini Abdul Aziz and Professor Maria Dr. Muhammad Faizal Ibrahim from UPM and Dr. Nahrul Hayawin Zainal from MPOB. This is the outline for my presentation today. As an introduction, Malaysia is the world's second largest palm oil producer after Indonesia. In 2018, the gross domestic product of palm oil was estimated to be approximately 38 billion Malaysian ringgit, which hold around 38% of the agricultural sector GDP. However, a large-scale production of palm oil contributes to enormous amount of oil palm waste, such as palm oil mill effluent or also known as POME, as you can see in the first picture. During milling process, palm oil industry produce about 48 to 72 million tons of POME per year. In Malaysia, about 85% of POME produce is treated by utilizing the conventional ponding biological treatment method. But this method is less efficient due to excessively high organic load and low pH of the POME. It also requires a large area for the treatment process to be done. Therefore, nowadays, the research interest seems to have shifted to the development of polishing technology such as adsorption technique for the removal of organic matter in wastewater. Activated carbon has a porous structure as you can see from the picture, surrounded by carbon atoms. Therefore, it is a material with absorbent capability. There are two problem statements for this research. First, many factories did not comply the discharge standard set by Department of Environment DOE, which had caused environmental pollution. Second, majority of current activated carbon are produced from non-renewable sources such as charcoal. Now move to the hypothesis of this research. The palm kernel shell activated carbon can remove residual organic pollutant and heavy metal from POME by applying the adsorption technique. Thus, the POME final discharge will comply with the discharge standard set by DOE. From figure 1, you can see the scanning electron microscope image of activated carbon before treatment and after treatment at 3000 times magnification. Here you can see at the red area is where the organic pollutant and heavy metals were trapped. The objective of this research is to analyze and assess the treatment efficiency of the laboratory scale treatment of POME final discharge by batch experiment. And the second objective is to develop the standard of the procedure SOP best suited for the treatment of POME final discharge. Here is the methodology that I will use for this research. First of all, preparation of palm kernel shell activated carbon by using a reactor. Next, collect POME sample at Suabetong Palm Oil Mill. Then, the POME will be run with activated carbon in an incubator shaker. There are two crucial aspects that will be focused on, which is first, the treatment duration, and the second one is the total absorbance taken for the most optimum adsorption by the activated carbon. This is crucial to analyze and assess the treatment efficiency. Lastly, POME will be tested with four analyses, which is BOD, COD, TSS, and color analysis. Next, let's move to the expected outcome of this research. After being treated with palm kernel shell activated carbon, the properties of POME are expected to meet the discharge limit standard set by DOE, which is below 100 mg per liter for BOD, below 50 mg per liter for COD, below 200 mg per liter for TSS, and below 100 platinum cobalt for color. Here is the references that I use. And I would like to thank you to all my supervisors for their guidance, MPOB, all my family members and friends. That's all from me. Thank you.